Is it understood? Is the indirect communication is understood? For mailbox sharing, what it does, that suppose P1, P2, P3 are sharing a mailbox A. As I said, multiple processes can have the same mailbox. So they let these three are sharing the mailbox A. P1 sends a message to A. P1 sends a message to A. Both P2 and P3 execute a receive from. So because we do not know that who has the message is from whom it has, we do not know. So both P2 and P3 will execute receive. Now who will get the message? Now in that message box, it has to be explicitly mentioned that for whom the message is intent for. The solution is that allow a link to associate with at most two processes. Allow a link to be associated with at most two processes. So that means the link has to be at least between only sender and receiver. Only one process at a time can execute receive operation. Allow the system to select arbitrarily. So even if you have multiple receivers, you allow only one receive at a time by creating only allowing only one link. The mailbox can be owned by process or by the operating system. So who will be creating this mailbox? This is be owned by the operating system. If the mailbox is owned by process, only that process can receive the message through that mailbox. When the process terminates, the mailbox disappears. So this mailbox is either being associated is being owned by the process or by the operating system. If the mailbox is owned by the operating system should create a new mailbox, send and receive messages through the mailbox and delete and that once it is done, the mailbox can be deleted by the operating system. So what are the operations that can be done? One is creating the mailbox, send and receive messages through the mailbox and delete the mailbox. Mailbox is just like a post box being kept. What are the operations? We'll create a mailbox, send and receive, all transmission will occur. Then once it over, we will delete it. So it is a logical. It is a logical one. Correct? So we have this is direct and indirect we have read. What is direct and indirect we have seen. Correct? These are all differences between direct and indirect. These are not there in direct links. So coming to the next one is synchronization. Message passing may be either blocking or non-blocking. The message passing may be either blocking or non-blocking. Blocking or non-blocking. What is blocking? Blocking is considered as synchronous and non-blocking is considered as the asynchronous. Correct? So this synchronization means it's either synchronous or synchronous or blocking non-blocking. What is blocking send? Blocking send. The sender is blocked, right? Blocking send means sender is blocked. When it will blocked? The sender is blocked until the message is received by the receiving process or by the mailbox. It says that the message is sent unless it is not being received at the receiver end or at the mailbox, the sender will not send the next one. The blocking receive says that the receiver is blocked until the message is available. Until the message is not available, the receiver is being blocked. So it is called the blocking send and blocking receive. Similarly for non-blocking send and non-blocking receive. Non-blocking send means the sender sends the message and resumes operation. So sender will not wait. Sender will go on sending the message. So there is no blocking. Sender will assume that the message is delivering. Similarly, for non-blocking receive, the receiver goes on receiving the messages. Even if the mailbox is empty, it will go and search and come back. Like that, it will go. So it is a non-blocking receive. The receiver receives, go on receiving. If nothing is there, it will go search and come back like that, right? Either in the box maybe a valid message is there, or no message might be there, or null message, correct? So what it will receive? It will receive either a valid message. If nothing is there, it will read a null message, right? So if both send and receiver blocking, then we have rangeovers between sender and receiver. So sometimes, both are blocking. Both are synchronous. That means sender is blocked until the message is not received, and similarly receiver is also blocked until message is not available. So we have another term is the buffering. The message exchange by communicating process reside in the temporary queue. So this buffer is either a zero buffer or automatic buffer. Zero capacity buffer means there is no, you just think of the queue has maximum length 0. So whatever I will send, it has to go directly. There is no temporary storage over here. No messages are queued on a link. Queue has maximum length 0. That means it doesn't exist over here. No messages are queued on a link. Sender must wait for the receiver. Sender must wait for the receiver. Sender must block until recipient receives the message, because there is no buffer, no queue. Correct? As there is no queue in between, so it will send and wait till it is being received by the receiver. The bounded capacity, similarly we have automatic buffering. One is zero buffering, another is automatic buffering. Automatic buffering is what? There are two types. One is bounded capacity, another is unbounded capacity. The buffering are of two types, bounded and unbounded capacity. Bounded capacity is what? Queue has finite length n. Sender must wait if link is full. That example we have taken in producer problem. A queue length is given, n number of items can be kept. When n, it has reached n, then it will say that we have the bounded, there is a bound over here. Then it will say that link is full. Unless it is not n, it will go on sending the messages. So producer will go on producing the elements unless the n is not reached. So queue has finite length n. Sender must wait if link is full. Otherwise, the sender can keep on sending without waiting. Without waiting, it will go on sending, and that will be what? That will be in the queue itself. There is an unbounded capacity. The unbounded capacity says what? Unbounded capacity. The queue has an infinite length. Practically, it is not possible that it cannot have an infinite length. But assume that is a very high, there is a length is very large, so you can have many messages can be kept. So queue has infinite length, any number of messages can wait in it. So if the queue has infinite length, then sender doesn't have to wait. Sender will go on producing, because it knows that there is no limit. Also go on producing the items, and here we say it is an unbounded capacity. Practically, or we can say literally, unbounded capacity is not that. There is some limit always. You have memory is always limited. It is not that you have unlimited memories there. But if you have very large memory is there, where many messages can be kept and there is no bound on that, then we say it is a unbounded capacity. Right? So we have read what? We have read about over here that one we have read about the shared memory and message passing. Then in the shared memory we have read about the producer consumer problem with the bounded and unbounded buffer. And in message passing, we read what? We read about the direct or indirect, synchronous or asynchronous, automatic and explicit buffering. Automatic buffering or explicit buffering. Direct and indirect, we have read about how the link is being established. In indirect, how mailbox is being used. Then synchronous and asynchronous, this is how the direct command, symmetric and asymmetric. And these are the main differences between the indirect and direct communications. Right. Then we have synchronization. We have read about the blocking, non-blocking, and in buffering we have read about the zero buffering and automatic buffering. Zero buffering means the queue length is 0. Automatic buffering has queue length n, so it may be bounded or unbounded buffering. Correct. So this is about the inter-process communication. So these are many conceptual things only. The theoretical things are. So you have to go through these slides again to understand because there are many things we have covered today. So you have to go through these slides again or go through this content again to know that to understand the concept. If you have any doubt, you will ask me in the next classes. There are some case study of these IPC inter-process communication. There are some case study over here. Those case study I am not covering over here. This will not be come in your exam. But however, if you want, there are some case study like the implementation of shared memory in POSIX, message passing in Mac OS, and Windows XP shared memory. These are there. If you want, these slides also I will be sharing you whenever this unit will over. I will share this so that you could able to know that how this can actually occur in different operating systems. But this is optional. It's not necessary to be. It will come in your exam. But however, if you are interested, you may go for reading these concepts or how this inter-process communication is implemented on this POSIX, Mac, or Windows XP. Correct. So next class we will go for reading about the thread and its issues. Correct. Okay. So now we'll go for the attendance. Then we'll go having the query. 2 weeks permanent at absent. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 22, 5, 30. Okay, let me again call the absent roll numbers. Roll number 2, 22, 25, 27, 30, 37, 39, 56, 67, and 73. These are the absent roll numbers.
Sir,
Hello.
present.
Hello.
Sir, 56 present.
56.
Hello.
What is your name? Oh, you have not given your roll number. 56.
Sir, Swapnil Naik. Sir, I have. Yes, sir. Sorry, sir.
Okay. Now, anybody having any doubt from today's class? You read it, and if it is there some doubt are there, you ask me in the next class again. Right? So I'll end this meeting now.